Hi, Integrated Math 2 students. It's Mrs. Robinson. I'm just going to work the practice benchmark chapter 3 and 4 for you, just so you can come here if you have any questions while you're working it. Normally we just have one chapter per benchmark, but this first one, there's two chapters per benchmark. So let's go ahead and work through them. The first question gives you two congruent quadrilaterals. Now you have to be careful when you label congruents to label them in the proper order. It tells us these are congruent, and then it says when WX is congruent to which side. It says then WX is congruent to which side. Now I can come down here and look at this, or I can just say, since these are written in the correct order, WX in this order should be congruent to JK. So I should know that right away, JK. Now if you look at the figures, here's WX, here's JK. And if I rotate this slightly, you can see that's true. This side should be congruent to this side. But you have to be careful when you label. You need to label them in the correct order. All right, let's go down to number 2. Scrolling down. And number 2, it says, given triangle FGH congruent to triangle QRS, GH is this, RS is this. Find the lengths of GH and RS. If I were to draw a quick triangle, and this is F, G, H, and then another triangle, and we'll label this one Q, R, S. They tell us that these two are congruent, so their parts are congruent. GH should be congruent to RS. They give us GH is 3x minus 2, and they give us RS. Well, if GH is congruent to RS, here's RS, here's GH, I'm going to mark them congruent. RS is x plus 6. If these two are congruent, I can just set these equal to each other and solve for x. Set these two sides equal to each other and go ahead and do the algebra. Gather your x's together by subtracting x to this side. Then you're going to get 2x minus 2 equals 6. And then go ahead over here and move this to the other side, your constant. And then you're going to get 2x equals 8. And then divide by 2, you're going to get x equals 4. So if I know x is 4, that doesn't give me my solution. I want to know GH and RS, the lengths of these. So I come over here to GH and I plug in 4. Well, 3 times 4 is 12. 12 minus 2 is 10. So GH will be 10. All right, now let's look at RS. I don't even have to plug it in because I should have 10. They're congruent, right? This should be 10. Just double check it, make sure you did it right. Plug in 4. 4 plus 6 is 10. They're both 10. Woohoo, we did it. That's how you can check your work on that one. All right, number 3 is a proof. It's weird when I scroll and that stuff doesn't move. All right, now we're going to give you some scaffolded proofs. Some of you might struggle with proofs. Where do I start? Proofs are great logical thinking for problem solving in general. Where do I start? Where do I go to next? How do I work this? What do I know? What do I don't know? Always start with what you know and work from there. All right, so let's see what we do know. We are given KJ is congruent to MN. So let's mark it. It's already marked, but I like to mark it in red so I can get this in my head. What do I know? KJL, this angle, is congruent to MNL, this angle. So now they're marked. Great. Now let's go to our proof. Well, let's first look at what we're trying to do. That is, prove this triangle JKL is congruent to this triangle NML. We want to prove these triangles are congruent. Now we have some ways to show that things are congruent. Let's just write them down. We know there's one way is angle side angle. There's side angle side. There's angle side side, or you can call that side side angle. There is not angle side side. And the one that spells the bad word is the one that you don't use. Angle side is what I meant to say, and side angle, okay? That is one that works, or side, side, side. The one that spells the bad word actually only works if you have a right angle, so we call that the hypotenuse leg. because you have to have hypotenuse and a leg to prove congruence, and the angle has to be a right angle. It can't be any angle. Okay, so here's our ways. Now, if I look at this scaffolded proof, I may not choose to prove it by angle, side, angle, but I can see in this scaffolded proof, that's the way I'm going to get to it. Angle, side, angle. Looking at this, I might do this. Hold on. All right, looking at this, I probably would say, I can see right away, just from what I know, that these are vertical angles and they're going to be congruent. So I'm just going to mark them here in blue. Now, if I know that, I can have angle, angle, side right here, and I can prove these two triangles are congruent really quickly. Now, this is a scaffolded proof, and they want me to use angle, side, angle. So I'm going to have to get this angle to be congruent to this angle in order to use angle, side, angle. All right, well, let's look at that and see how we could do that. If I do know these angles are congruent because they're vertical angles, and I was given those angles are congruent, well, I know these angles are congruent by the third angles theorem. Two angles in one triangle congruent to two angles in another triangle, the third angle has to be congruent because in a triangle, angles add up to be 180. And that's all that's left for these two triangles. If I take 180 and I subtract these two, I'm going to get a certain amount. And if I take 180 and I subtract these two, I'll get that same certain amount because these are congruent to these. That's the third angles theorem. If you know two angles, there's no other thing for that third angle to be but the same as this. All right. So by doing that, I can get angle, side, angle. So let's walk through this. First of all, we have our given, and we marked it already. That's our given. Then we go angle KJ or KLJ is congruent to MLN. So this is KLJ. Let's try that again. KLJ, this vertical angle, is congruent to MLN. So these vertical angles are congruent. If I could spell vertical, that would be awesome. I don't know why I went EL or LE, whatever I did. Okay, vertical angles are congruent. All right, so let's do that. And then the third angles theorem. That's going to give us these angles being congruent. So we're going to go angle K is congruent to angle M. That's the third angles theorem. Then finally, these two triangles are congruent by angle, side, angle. So I just go, okay, well, triangle KJL. Now, it doesn't matter what order you put this in, as long as you do the second triangle in the same order. KJL, I need to have corresponding angles. MNL, so triangle MNL. And these triangles are congruent by angle, side, angle, and you're finished with that one. All right, on to the next one. Number 4, name two triangles that are congruent by angle, side, angle. That same one we just did, angle, side, angle. That's the one we're going to use. So analyze these triangles. This one has a 1 marking, so an angle, a side in between, and an angle. So this would be angle, side, angle. Let's look at this one. It has a 1 marking and a 2 marking. Also angle, side, angle, a side in between. This one's got 2 angles and a side, but this is angle, angle, side, or if you'd like to say side, angle, angle. It does not have a side in between like these two did. So nope, it's not that one. Angle, side, angle would be these two triangles. And I would say triangle RQS is congruent to triangle. Since I started here with the 1 angle marking, I start here with the 1 angle marking. T, and then I went to the 2 angle marking with the Q, so I go to the 2 angle marking with the U, T, U, V, T, U, V. And there you have it. Make sure you label it in the proper order. On to the next one, number 5. And I gotta clear that off. Okay, based on the given information, what can you conclude and why? All right, let's see what we got. We see AE bisects BD. So if AE bisects BD, you know this is congruent to this. Doesn't necessarily mean it the other way around. This is the bisector. BD is the bisect E. It's the one that got bisected. Okay. Now we go and we say, well, BD, this guy, bisects this guy. So now this guy gets bisected, AE. We double mark it. Okay. Now we have some sides congruent here. That side congruent to this side congruent to this side. I can easily do that vertical angles again right there. Done. Now I've got side, angle, side. Side, angle, side. So by side, angle, side, I can get these triangles congruent. So based on the given information, what do I have here? What can you conclude and why? Well, I'm going to go ahead and say triangle ACD, ACB is congruent. Now, since I started up here with A, where the double marking is, and I went to C, this side first, it's congruent to this side. So I start here with E, where the double marking is, and go to C. So I'm going to go E, C, D. So ACB is congruent to ECD. Label it in the correct order. By the way, I think the answer key actually does not label this in the correct order. And let me see if it does. I think the answer key labeled, yeah, I think it goes A, B, C, and then D, C, E. Yes, shame on that. I pulled this from a workbook. I am going to have to fix that. The answer key labels it in the incorrect order. Nonetheless, these triangles are congruent by side, angle, side. Okay, so it says based on the given information, what can you conclude? Whoa, I can't say it. What can you conclude and why? I can conclude those are congruent by side, angle, side because the vertical angles are congruent. Okay, on to the next one. I'm having a hard time talking today. I'm trying to go through this quickly, and you guys can pause it if you need to go slower. Supply the missing reasons to complete this proof. Once again, it's scaffolded. You don't have to worry about doing the whole thing. All right, so you're given BD. Hold on. Okay, on to number 6. We're given a scaffolded proof, like I just said, and you are given this information. Now, I always like to mark up my proofs first thing so that I can work through my mind what information I have. So the information I have here is BD is perpendicular to AB right here. And then I mark it with a perpendicular right angle because when I have two perpendiculars, they meet at right angles, okay? And then also BD is perpendicular to DE, so I'm going to mark that with a right angle. Then I know BC right here is congruent to DC right there. I want to prove angle A is congruent to angle E. That's what I want to prove. Now, thinking through this, as I work through this, I'm going to look at these two triangles. Okay, if I could get these two triangles to be congruent, I could get A congruent to E because I know if I have two congruent triangles, all their parts are congruent. And that's one of the theorems I learned in these chapters. Congruent parts of congruent triangles are congruent. So let's go and walk through our scaffolded proof and see what it gives us. How can we get these triangles congruent, first of all? Let's look at that. Once again, that vertical angle will help you every time. You know it's congruent. It's an easy go-to. And I'm just going to mark it there. Vertical angles are congruent, and I can have angle, side, angle. Right away, I can see that these two triangles are going to be congruent, and then these parts will be congruent. Let's just go write it down, okay? Let's go here. The perpendiculars, that was given to us. We always start with the given. Then we go, angle CDE and CBA are right angles. It's just saying these two are right angles. Well, where it was given the perpendiculars meet at right angles. So we just go ahead and state this. These are right angles by the definition of right angles. Two perpendicular lines meet at right angles. Okay, so we state that those two are right angles. Then we state that CDE, this angle, is congruent to CBA, this angle. Well, they're both right angles, so they're going to be congruent, right? All right angles are congruent. And that's all you have to write for that. Now I have a blank, but it says vertical angles are congruent. Well, I just go to my vertical angles. These guys are congruent. I know that, so I'm going to go ACB, angle ACB. I went ACB is congruent to ECD, angle ECD. Make sure the angle's in the middle. ECD, that's your angle. Make sure that guy's in the middle when you're labeling it. Vertical angles are congruent. Bam. All right, then we go BC is congruent to DC. BC congruent to DC, well, that was given to us. Just remember that was given. Okay, so now look, I've got angle, side, angle. So The last step right here, I'm going to write, well, my triangles are congruent. Triangle ACB, make sure you label these in the correct order. ACB is congruent to, you can start any way you want, but your second triangle is what matters, how you label in order. Make sure you label the correct angle with the correct angle and the correct side with the correct side. So if I go long side ACB, I have to come over here and go long side ECD. Those are my congruent guys, and they are congruent by angle, side, angle. Angle, side, angle. Angle, side, angle. So since we've done that, now we can say that's congruent to that. And that's our last step. And I have to scroll down, so it's going to make everything pull up. So it's going to pull all our markings off their places. But that last step right there, see, it pulls all our markings. So that last step, we're just going to go, and I'm just going to write it here. Congruent parts of congruent triangles are congruent. That's why angle A is congruent to angle E, because congruent parts of congruent triangles are congruent. Okay, now I can scroll back down and things will be back in their places. Except for you won't see that last step. And now everything's out of their places. Yeah, there they go. Now they're in their places. And congruent parts is up there. Very strange, but that's how this program works. Okay, so that's number 6. Let's go on to number 7. What is the value of x and y? All right, looking at this, I can figure out a few things. This is a straight line, so that means that these have to be 180, supplementary. I also know the exterior angle is equal to the 2 remote interiors for that same reason. These have to be 180 when I add up the angles of a triangle. These have to be 180 when I add them up. So this and this has to be 180. This, and this has to be 180. So that's going to equal those two. Exteriors equal to the 2 remote interiors. Well, let's see. I've got this marking and this marking here. Awesome. This is an isosceles triangle. That means, I just made it blue. That means that this angle is congruent to that angle. Great. So here's what I can do. If these two make 180, I'm going to go 180 minus 135. And then when I do that, I'm going to get 45. And here, if this is 45, that's a 4, not a 9. Then this is 45. And 45 and 45, and I've got 180 minus 45 to get this. So 90 is 45 plus 45, and if I do 180 minus 90, you guys should just know that it's 90. So I have 90 for that. So my x is equal to 45, my y is equal to 90. Know your theorems, and you can figure this out really easily. All right, let's go on to number 8. The wall at the front entrance of the Rock and Roll Hall of Fame and Museum in Cleveland, Ohio is an isosceles triangle. Like this guy, let's draw him. Yay, isosceles, okay. The triangle has a vertex angle of 102. What is the measure of each base angle? Well, what's the vertex angle? What's the base angle? These are my base angles because I have an isosceles triangle. So that would make this my vertex angle, which is 102. Once again, testing this concept. Triangles add up to be 180. These are this is an isosceles triangle, so these are the same measure. So I just go 180 and I subtract off 102. And if I do the math on that, 80 and then 2 less, it's going to be 78. Simple enough. But there's 2 angles to split that 78 between. So you just divide by 2 and you're going to get 39. So each base angle should be 39. If I did that right. Trust me. All right, clearing that off and moving on to the next. Number 9, what additional information would prove the pair of triangles are congruent by hypotenuse leg? Now, hypotenuse leg means you have to have a right triangle to have an hypotenuse. It's the one that spells the bad word. It's angle, side, side. But the angle has to be a right angle, and the side, one of the sides has to be a hypotenuse. Okay, so that's why we call it hypotenuse and a leg. So it says, what additional information would prove that the pair of triangles are congruent by hypotenuse leg? So what, once again, to use hypotenuse leg, you have to have a hypotenuse congruent and a leg congruent. Here we have right angles. What else do I have congruent? Well, TS is congruent to itself. TS is TS. So I know one leg already. I just need my hypotenuse. I need this hypotenuse to be congruent to this hypotenuse. That's what I need. I don't have that. Okay? So what do I need to use hypotenuse leg? I need TR, this side, to be congruent to TB, this side. I need the hypotenuse. I have a right angle. I have a leg. I need a hypotenuse. That's what I need. All right, on to the next one, number 10. What common side do ADC and triangle BCD share? All right, so you can break this one apart. What common side do they share? ADC and BCD. If you are one that is not a visual and you want to break these apart, you can do it like this. Hold on a second. Okay, you can just break these apart and just draw them like this if you need the visual of them broken apart, but you should be able to see which side they share because it's on top of itself. Okay, and you can see DC is the same in both. This is the side they share, DC. All right, on to the next. Number 11, let's clear that off. Are triangles GHJ and IHJ congruent? Justify your answer. Well, how could I show these triangles are congruent? What's justify my answer mean? All right, justify my answer means give me a reason they're congruent. Why are they congruent? Angle, side, hypotenuse leg, all the parts are congruent, so the triangles are congruent. What is it? Okay, so let's look. We have this congruent to this. We have this congruent to this. That's a right angle. You have so many things to prove congruence here. This is congruent to itself, so we're going to mark that. So you could do hypotenuse leg even without that. Already you could have hypotenuse leg. Already you could have, look, that marking and that marking. You could have angle, side, angle. Angle, side, angle. Already you could have side, side, side. Side, side, side. Basically, we have all the angles and all the sides congruent here except for these right here. This angle and this angle. Are they congruent to each other? Well, yeah, because of the third angle theorem. If two angles in one triangle are congruent to two angles in another triangle, then the third angles are congruent. So we have all the angles, all the sides congruent. So are these congruent? Yes. Okay. Now, what is the reason they're congruent? You could give me a variety of reasons and I'll take any of them. I'll take side, 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 angle, side, angle, hypotenuse leg, third angle theorem, giving me all the parts are congruent, okay? I'll take any of that. So basically by the definition of congruent triangles, okay? You could use that by the definition of congruent triangles because you have given me HJ is congruent to itself because of the reflexive property. And then you have the third angles theorem to give me this. So basically you just have it all. You have it all. Okay, let's go on to number 12. Is there enough, oh, let's clear that off. Okay, is there enough information to prove the two triangles congruent? If yes, write the congruent statement and explain the theorem. If not, write not possible and tell what other information you would need. Make sure you do both those things. Yes or no. If yes, how? If no, what else do you need to prove congruence? Okay, so make sure you do that on the test. This will be a free response part in the test. I'll be reading it. All right, look what we've got. We've got angle, side, side. Anytime you hear that, angle, side, side, it spells a bad word, red flags. The only way you can use the angle, side, side is if you have a right angle, and we do not have a right angle. A right angle would be marked with the square, and it's not, so it would be marked like this. It's not. So we cannot use what we have here. I'm going to go no. We have angle, side, side, and it's not a right angle. It's not hypotenuse leg. So what other information could we use to prove congruence? Well, if we had this angle here, that would be great because then we'd have side, angle, side. So that's one thing. How about if we had angle HJN and angle, let's go HJN, RFD. If we had those, then we can prove congruence by side, angle, side. Side, angle, side. There's lots of other things you could do. What if we had this third side? If we had this, you could have also said, oh, if we had side DR and NH, then we would have side, side, side. Okay, there's more than one way to do this. All right? Just give me a reason. Okay, no, but if we had this, we would have side, angle, side. So make sure you say no first. And then let's go to 13. Number 13 is one of the theorems that you have, I think section 4.1, and it is the midpoint triangle theorem, I believe. Is the mid-segment of triangles. I have midpoint, mid-segment. So the mid-segment of the triangle theorem basically says, if you connect the two midpoints of two sides of a triangle, this third side right here is going to be parallel to the mid-segment, this mid-segment, okay? It's also going to be half the length. So what's the length across the lake right here? It's half that. You just have to know that theorem. Make sure you study it. It's in section 4.1. This is going to be half of that, and it's going to be parallel to that when it connects the midpoints of the two sides of the triangle. So that would be, I wrote 4.1 because that's the section it's in. Okay, that's a section. That's not the answer. The answer is 3.5 kilometers. If this is 7 kilometers, this is 3.5 kilometers. All right, and on to the next. All right, 14, let's clear that off. 14, which statement can you conclude is true from the given information? AB is perpendicular to IK. Well, if AB is perpendicular to IK, oh, and it's the bisector. AB is the perpendicular bisector of IK. Let's mark what we know. If AB is perpendicular bisector, we know it meets at right angles right there. Okay, so all four are going to be right angles. And then it bisects IK, so these two sides will be congruent. It does not necessarily mean these are congruent. No, 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 you don't know that. It does not say IK bisects AB. It doesn't say that. It says AB is the perpendicular bisector of IK. So these are congruent. So let's go through it. Which of these can we conclude is true? Angle IAJ, so IAJ is a right angle. This angle right here, that's not even formed, that's a right angle? No, we don't know that. We haven't even formed that angle. So it's not that one. A is the midpoint of IK. A is the midpoint of IK. Do we know that? Okay, we'll come back to that one. C, IJ equals JK. So IJ, this, equals JK. I'm going to go with that one. That one sounds pretty good. IJ equals JK. Yes. Right? Yes. And then D, AJ equals BJ. Well, we don't know these are congruent, remember? We're not sure about that. All right, so let's undo that one. We don't know because it did not say IJ bisects AB. It did not say that, so we don't know that. Now let's come back to B. Okay, so we know it's not this one again. Come back to B. A is the midpoint of IK. Well, A is on the perpendicular bisector, so we do know this length. Ooh, so let's try that again. We do know this length will be congruent to this length. However, is A the midpoint of IK? No, it would be J. This is the midpoint of IK, so it's not that one. All right, so it would be C. All right, clear that off, and then on to the next. We're to 15. AC bisects angle BCD. Find the value of X. This diagram is not to scale. This guy, AC bisects angle BCD. So those two are congruent. Good. All right, we want to find the value of x. So let's look at what we have. All right, looking at this, if we know that A is on the bisector of this angle, we know A is going to be equally distant from the sides of the angle. So that means this will have to be congruent to this because A is on the bisector, the angle bisector. So A is going to have to be equally distant from this side as it is from this side. So these two will be congruent. To find the value of x, we simply set this equal to this. 5x minus 3 equal to 3x plus 1. Time for a little algebra. All right, gather your x's together on one side by subtracting 3x to both sides. Got to keep your equation in balance. Do the same thing to both sides. Subtract and bring down. You're going to get 2x minus 3 equals, bring this down, 1. Now add 3 to both sides. And that eliminates that. You get 2x equals 4. Divide by 2. You're going to get x equals to 2. Now we figured out the value of x and we're finished with that one. All right, on to, let's do the mouse and clear that. Okay, find the circumcenter. Now, the circumcenter, the orthocenter, the centroid, all of those are centers of points of concurrency is what I meant to say for all of your triangles and their angles. So what you need to know is which one is the circumcenter, and I'll tell you which page you should study this on. It's on page, hold on, let me look. Okay, so you're going to find a little review on page 227 of your workbook on circumcenter, incenter, centroid, orthocenter. So your circumcenter is your perpendicular bisectors. Your angle bisectors is your incenter. Your medians is the centroid, and your altitudes is the orthocenter. So it asks us for the circumcenter of the triangle. If we want to know the circumcenter, we need to know that is the perpendicular bisectors, okay? So what does perpendicular bisector mean? Each side will have a line that bisects this segment and is also perpendicular to the segment. Now, instead of doing a bunch of calculations on this one, where I would go, all right, to find where it bisects, I need to find the midpoint. So I would use midpoint theorem, okay? Add the two x's, divide by 2, add the two y's, divide by 2. Or, since I'm on a grid, it's really easy to see it. Here, this length is 2, so halfway is going to be right here. And since I'm on a grid and this is a vertical line, the horizontal will be perpendicular. So just draw it. Make it simple. Don't do a bunch of calculations you don't need to do when it's obvious right there. Okay. So this is the bisector of this segment, and it's also perpendicular to this segment. Since this is a vertical line, the perpendicular will be horizontal. Now let's come to this segment. It's 1, 2, 3, 4, 5 across, so halfway will be 2.5 across. So 1, 2.5 right here. This is horizontal, so I'm just going to make a vertical line here. Now there I've got a point. Now, the circumcenter will go through where all three meet. There is a third, and since this is on the diagonal, I would have to use the midpoint theorem to figure it out. I would use this point, which is over 6 up 1, and I would use this point, which is over 1 up 3, to find the midpoint. And then I would have to graph by compass the perpendicular bisector for that. However, if I've already got 2 points, I know my third point's going to meet right there also. That's where they're going to all meet. They all meet at the same point, so I don't even have to draw the third. Just use the 2 you already know. Bam, you have your solution. Okay, so I'm over. Let's figure out what this point is right there. That is the circumcenter. So let's write that point. That point is over 1, 2, 3.5. It's over 3.5, over 3.5, and up 1, 2. It's 3.5, 2, and you're done. You didn't even need that third point for that third perpendicular bisector. Just make it easy for you. Okay. All right, let's talk about the centroid. The centroid has a little theorem that goes with it. Now, the centroid is the medians, and I'm going to tell you what page that little theorem is on, so if you want to go review it. Sorry, the centroid is the center point where all the medians meet, okay? So the median comes from the vertex, and it comes to the middle of the opposite side, so like that would be congruent to that. Oh, not that. So this section congruent to this section, and then from this angle it goes to the middle of that side, so that would be congruent to that. From here it goes to the middle of this side, so this would be congruent to this. That's your medians. That's the centroid. Where all the medians meet is the centroid there. Now something cool happens when you have a centroid, and a particular correlation happens with the sides and the angles. And I know it's somewhere in your book. Let me just see. Oh, I found it already. It's page 223. If you want to review this theorem, you're going to need it for the test. Make sure you know centroid. It has some relationships with the lengths of the medians and that middle point. So all of the lengths of the medians, this will happen. It doesn't matter if it's this one, or this one, or this one. They'll each have a long section and a short section. And how it works is the long section will be 2/3 of the whole, and the short section will be 1/3 of the whole section. Now I'm using W for whole section, not that W. I'm just using W for the whole section. So you have the whole length of the median. The long part will be 2/3 of the median, and the short part will be 1/3 of the median. It's a cool little trick that happens when you have centroids. So in this problem, they give us CW. CW is this long part here. Okay, that's the long part. They tell us it's 15. They want us to find the short part here, CX, or the long part here, CX, and the little part here, XW. Okay, so they give us the big part, it's 15. Now I know the long part is going to be 2/3 of the whole. So I just go 2/3, and the whole piece is 15. So it's 2/3 of 15. So CX equals 2/3 of the whole. Find CX? Well, that's easy. 3 divides into 15 5 times. 5 times 2 is 10. So CX equals 10. If CX is 10 and the whole part is 15, you know this is 5. Or you could come over and be like, oh, the little part is 1/3 of the whole. So the little part, which is XW, that is 1/3, I almost wrote 2 again, 1/3 of the whole, which is 15. And then 3 divides into 15 5 times. 5 times 1 is 5. So XW equals 5. So you can check it, or you can do it the easy way and just figure that out. There you have it. That's how you do that one. Make sure you review that though. All right, clear that off and on to 18. What is the best name of segment AB? Segment AB, well look, it comes from the angle and it comes to the opposite side, bisecting the opposite side. So what does that? What comes from one side and bisects the opposite side? Okay, this has the word bisect in it, but it's not necessarily a perpendicular bisector. However, it could be. This could also be the perpendicular bisector. Sometimes 2 of the lines that you're looking for, or the segments, actually do more than one thing. The only way I could know it's a perpendicular bisector is if this were a right angle and I knew it was perpendicular and it bisected. And I don't know that, but I just know that it cuts the opposite side in half. So I know I have a median. It comes from the angle, the vertex, to the opposite side and it cuts it in half. That's called a median. Make sure you know those definitions. What do perpendicular bisectors? What do altitudes do? Altitudes just drop perpendicular to the opposite side. It doesn't have to bisect it. Perpendicular bisectors have to drop to the opposite side and bisect it, but it doesn't have to necessarily come from the vertex. Medians have to come from the vertex, cut the opposite side. So make sure you know the details on all those different types. Okay, explain why. Explain why angle 1 is greater than the measure of angle 2. How do I know that? How do I know angle 1 is greater than the measure of angle 2? All right, if you're not sure of the theorem, I'm going to tell you where it is. It's in section 4-6. I say dun 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 a lot. Sorry about that. It's in section 4-6, and I can speak. All right, so this guy says the exterior angle, and let me read it so that I don't say it incorrectly. The exterior angle theorem says the measure of an exterior angle of a triangle is greater than the measure of each of its remote interiors. It's actually a corollary to the triangle exterior angle theorem. The triangle exterior angle theorem is the one we talked about just a minute ago, where the exterior angle is actually equal to the two remote interiors, the sum of them. And we know that because this makes a straight line, so they add up to be 180. These are in a triangle, so they add up to be 180. If this plus this is 180, and these two add together plus that to make 180, well, that means this has to equal those two. It's the exterior angle theorem. This equals this plus this, okay? Now the exterior angle inequality says, well, if the exterior angle equals this plus this, then this has to be greater than any single angle. Added together, they equal that. So just alone, 1 will be greater than 2, or 1 will be greater than 3. Okay, so why? Because, what would you say? Because the measure of an exterior angle is greater than any of the two remote interiors. All right, and that is a theorem in section 4-6. Go look, it's a corollary. Okay, if you're not sure about that one or you didn't learn it very well, go back and review that one. All right, let's do number 20. I kind of like number 20. It's kind of fun way to look at a triangle. Draw a diagram. Walk it out. Think about it. So as we read this, we're going to draw. Jay, Kay, and Ray found themselves far apart when they stopped for lunch while working in a field, because that's where they work. Okay, J, K, and Ray is funny to me. J, so I'm going to write J. He's here first. He could see K, so let's put K right here. J could see K. He's looking this way, he could see him. Then he turned through 73 degrees. So J was looking at K, then he had to turn 73 degrees to see Ray. So he's looking this way. He had to turn 73 degrees to see Ray. He's over here. Okay. Kay could see Ray. So Kay's here. She's looking this way. She can see Ray. But then she had to turn through 53 degrees to see J. So she's looking this way. She had to turn 53 degrees to see J. All right. Now we can figure out this angle based on the triangle sum theorem, but they give us that. Ray could see J, but he had to turn through 54 degrees to see K. So he's looking this way, he had to turn 54 degrees to see K. Now, if this is all correct, these should add up to be 180, and that's a little, and they do. 73 plus 54 plus 53 does make 180. So this is the question. Which two were the furthest apart? So knowing that he had to turn 54 degrees to see, and J had to turn 73 degrees to see Ray, and K had to turn 53 degrees to see J. Just knowing that how they had to turn to see each other, you can figure out who's the furthest apart. And this is how you figure it out. You know a theorem, and if you'd like to know the theorem, I'll tell you where it is. Let me look, 1 second. If you look on, let's see, 242, I believe. And then you can use theorem 33 and theorem 34. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. And it's just a simple concept. If you have an angle and this right here, this side's going to be bigger. If this angle gets smaller, this side's going to get smaller. Okay? The angle that I made with my arms. It's big and then it's small, okay? So as the angle gets smaller, the side opposite it gets smaller, right? So here, and I like to do it like this, if I were to have this side and that angle got smaller, you can see this side would get smaller, right? That side opposite would get smaller. So, which side is the longest side? Well, across 73 would be the longest side. Across 54 would be second, and across 53 would be smallest. So across 73, we're going to say RK is the longest side. So which two are furthest apart? Ray and K. Ray plus K, they don't like each other. Okay, so let's go to 21. The two sides of a triangle have lengths 25 and 10. Write an inequality that represents the possible lengths for the third side of x. That is also in that same section. I believe it's the theorem. Okay, that is theorem 35. And it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And that's just this thing. If I have a length of 10 and a length of 25, okay, what could the third side be? Well, I could swing it in like this, possibly all the way to there. Maybe the third side could be that. So 25 minus 10, or I could swing it all the way. It could be a really, really big third side, almost to where they're the point that they're straight, where it's 25 plus 10. It just has to be a little bit less so I can actually connect and make a triangle. So this is the easy way to do it. Instead of doing 3 different inequalities like the text probably has you do, where you would go, oh, well, any two sides has to be greater than the third. So 25 plus 10 needs to be greater than the third side. And then I would do 25 plus x needs to be greater than 10. And then I would do x plus 10 needs to be greater than 25. You can do those 3 inequalities because any two sides together has to be greater than the third side. Or I could simply do this. If I have two sides, 25 plus 10, when they're straight, that's going to be my biggest length I could possibly be. So 25 plus 10, that's 35. That's my top, okay? And then I'm going to go 25 minus 10 when I swing it down. 25 minus 10 is 15. That's my lowest. So what is the possible lengths for x? X has to be less than 35. That would be my top. And it has to be greater than 15. So you just add the 2 to get your max, and you subtract the 2 to get your bottom, the least amount you could possibly go. Right? Instead of doing the 3 inequalities, it just makes it quicker. Okay, let's go on to 22. What's the range? Let's clear this. What's the range of possible values for x? The diagram's not to scale. All right, looking at this one, this is once again that hinge theorem. If you look and you're given the corollary, okay? So you're given a triangle, and okay, this one is the corollary in section 4.7, okay? Because we're dealing in 2 triangles right now, not 1 triangle. We've got 2 triangles here. Corollary 4.7 is the hinge theorem, but it's the converse of the hinge theorem for 2 triangles for side inequality instead of side congruence. And this would look like this. These 2 sides are congruent. You know this side's congruent to itself because it's the same side. So you have 2 sides congruent in one triangle to 2 sides congruent in another triangle. The third sides are not congruent. Okay, so you don't have congruence. You have triangle inequality here. You got 2 sides here, and you've got this side here. So you've got 2 sides in this triangle congruent to 2 sides in this triangle. The third sides are not congruent. Well, this side is a little bit bigger than this side. So the hinge theorem, or the corollary of this hinge theorem for inequality says, if this side's a little bit bigger than this side, then this angle is going to be bigger than this angle opposite it. And it makes sense. It's like a door. If I have 2 sides of the door, my wall and my door are fixed. But how far I open the door isn't fixed. So I can open it this wide, and then this length will be shorter, or I can open it this wide, and this length will be longer. This angle will depend on that, right? So I don't know if you could see that, but it's the door, it's the hinge. So since this is bigger, this angle has to be bigger because these 2 sides are fixed in both triangles. So I'm just going to go, well, 70, I lost my pen. So 75 is going to be greater than x minus 13. Now we have a lower limit 2, And in the lower limit, you don't want this angle to be 0. So it has to be at least greater than 0. And then just solve for x. Add 13 to all 3 sides. Eliminates that, and you're going to have x is greater than, there I am, 13, and x is less than 75 plus 13, which is going to be 88. And there you have it. That's your range for x. All right, so let's go on to 23. All right, number 23 is about indirect proofs. And indirect proofs are kind of cool. You start out with what you're given. First, you assume that what you're given isn't true. You assume the opposite. You negate it. You contradict it. How do you do that? Let's talk about that. Then after you contradict it, you go about making steps to show that your contradiction is false. So then you go back and you're like, well, my assumption must be false, so what I was trying to prove must be true. It's like you contradict yourself and you get to where you want to go. So all you have to do here is to prove if a number ends in 0, then is not divisible by 3 using an indirect proof. I didn't ask you to do the whole proof. All you have to do is tell me your first step. What would your starting assumption be? So you would assume temporarily that if a number ends in 0, then it is not divisible by 3. That not or that is what you want to contradict. So you're going to change that to it is divisible by 3. You just say, if a number ends in 0, then it is divisible by 3. And there is your first step. Then you go about showing how that can't happen, and then your original assumption is false, so this must be true. Okay? But you don't even have to do that. Just do the assumption. The nots become is's. The is becomes nots. That's all it is. All right? On to the next one. 24. We're almost there. 24. Can the 3 segments with the given lengths form the sides of a triangle? Explain. Okay, remember, 2 sides added together need to be greater than the 3rd side. Okay, 2 sides added together need to be greater than the 3rd. So let's see if it works. Okay, so we need to see if 3 plus 11 is greater than 7, 7 plus 11 is greater than 3, 11 and 3 is greater than 7. Every 2 side has to be greater than the 3rd side for it to make a triangle. So we're just going to go 3 plus 11 and see if it's greater than 7. Well, yeah, because 11 is greater than 7, so 14 is going to be greater than 7. Check. Now let's do 3 and 7. 3 plus 7, is that greater than 11? Well, 7 and 3 is 10. 10 is not greater than 11, so this is a no. No, because 3 and 7, 3 plus 7 is not greater than 11. Okay, and the last one, what is the negation to this statement? So that's once again to our indirect proof. Okay, what's the negation to this statement? There are more than 50 apples in a box. So whatever the key word is, not, more, less, 3, you just want to negate it. So instead of saying there are more than 50 apples in this box, you would say there are less than or equal to 50 apples in the box. And that negates that statement. And that's what you would assume temporarily. There are less than or equal to 50 apples in the box. All right, guys, that should get you going on your practice benchmark. Let me know if you have any questions.